Let us see a question of GATE 2022 which is of numerical answer type and which carries 2 marks. The question is, the initial value problem dy by dx is equal to f of xy with y of x0 is equal to y0 is solved by using the following second order Runge-Kutta method, which is given by k1 is equal to h into bracket f of xi comma yi, k2 is equal to h into f of xi plus alpha h comma yi plus beta k1, and yi plus 1 is equal to yi plus 1 by 4 k1 bracket of k1 plus 3 k2 with I is greater than equal to 0, where h is a uniform step length between the points x0, x1, x2, so on xn, and yi is equal to y of xi. Then the value of the product alpha into beta is dash, and they said that round off to 2 decimal places. So we have to round off the answer to 2 decimal places. So what they are given is, they have given a second order Runge-Kutta method, so which is given by yi plus 1 is equal to yi with the k1 and k2 values. Now we have to find what is alpha and what is beta. So here alpha and beta are mentioned in k2. So before that we have to see what is the general second order Runge-Kutta method, so that it will be helpful to solve the current problem. So the general second order Runge-Kutta method is given by yi plus 1 is equal to yi plus w1 k1 plus w2 k2, where k1 is equal to h into f of xi yi and k2 is equal to h into f of xi plus alpha h yi plus beta k1, such that w2 alpha is equal to half and w2 beta is equal to half. The general second order Runge-Kutta method is given by yi plus 1 is equal to yi plus w1 k1 plus w2 k2, where k1 is equal to h into f of xi comma yi and k2 is equal to h into f of xi plus alpha h yi plus beta k1, such that w2 into alpha is equal to half and w2 beta is equal to half. So using these relations, w2 into alpha is equal to half and w2 into beta is equal to half, we have to solve the given problem. So we can check here. So the given problem looks like yi plus 1 is equal to yi plus 1 by 4 k1 plus 3 by 4 k2 with k1 is equal to h into f of xi comma yi and k2 is equal to h into f of xi plus alpha h yi plus alpha k. Now comparing equations 1 and 3, we get what we get, w1 is equal to 1 by 4, w2 is equal to 3 by 4, and comparing 4, we have only alpha only. Now using, we don't compare, just use the relations, make it as E. So using the relations in A, we have, so w2 is 3 by 4, w2 into alpha is equal to 1 by 2 gives 3 by 4 into alpha is equal to 1 by 2, and w2 into beta is equal to 1 by 2 gives 3 by 4 into beta is equal to 1 by 2. So now we have to find what is alpha and what is beta. So this gives alpha is equal to 2 into 4 by 3, this is nothing but, no, this is not 2, this is 1 by 2 into 4 by 3, 1 by 2 into 4 by 3, so this is nothing but 2 by 3. So here also beta is equal to 1 by 2 into 4 by 3, so this is 2 by 3. Therefore what we get, alpha is equal to 2 by 3 and beta is equal to 2 by 3. Now what we have to find, we have to find the product alpha into beta. Therefore alpha into beta is equal to 2 by 3 into 2 by 3, this is equal to 4 by 9, so this is approximately equal to 0.44. Actually it is 0.4444. We have to round off to 2 decimal places, therefore the round off is 0.44. Therefore, the value of the product alpha into beta is 0.44. So, this is how we can solve the initial value problem using the general Runge-Kutta second order method.